thanks so much for being here at the GraphQL or tRPC data discussion. It took a lot to make this all happen, and so I want to start off, of course, by thanking the people that helped make this happen. Of course, Prisma, our sponsor Prisma, and so we actually have a representative here, Dan Starnes in the back. There he is. You can all see him. Thank you so much, Prisma, for making this happen. So I've known Prisma back when it was GraphQL. So back in those old days, they rebranded over to Prisma, and these days it just kind of makes sense to use if you're using any sort of data ORM. I mean, I'm curious, how many people are using Prisma already? Wow, that's okay, good. That's how it should be. So for those of you online, if you didn't see that shot, basically everyone here is using Prisma. So if you're not using Prisma, then you should. And thanks so much for Foolproof. I mean, the office that you're in today, obviously the Foolproof office is beautiful, amazing. It can fit the excess of people that we expected today. We weren't expecting this many people due to the rail strikes and et cetera, happening in London right now. So thank you all so much for making it out. It means a lot to us. For you to be here. And of course, thanks to Aris from Foolproof, who's right here. And so, yeah, that's everything in terms of sponsors and safety for the evening. So by now, I'm sure you're wondering, essentially, who the heck is this guy? Who am I? What am I doing up here? And what's this all about? Well, a bit about myself. Back when I just started programming, I saw this quote from this guy. And so to read it out, it said, "Bad programmers worry about the code. Good programmers worry about data structures and their relationships." And when I was young and didn't know better, I thought this guy probably knows more than I do. I kind of listened to him, and I started, getting massive books about data structures and algorithms, really researching data architecture, and that's kind of brought me through to this day. So this picture here was 14 years ago. I look basically the same, of course, still young and handsome. And I'm probably talking about something data structures back then, and I'm talking about data architecture today as well. So it was kind of surprising for me when my buddy Phil said, "Oh, Taz, this tRPC thing, it looks terrible, it looks so bad." I'm just like, "Phil, wow, okay, geez, Phil, wow." And then my buddy Alex said, "Oh, this GraphQL thing is horrible." And I'm just like, Alex, wow, geez, oh my goodness. And so I'm hearing this from both of these people that they just want to get into a fight. And so I'm just like, wow, okay, guys, calm down. I thought I'll take to Twitter and kind of provide some sanity to their crazy rhetoric. And so I said, I don't think it's that simple. RPC is good, GraphQL it's not that simple. There's multiple things to be concerned with here. It's not quite as simple as this thing's good, this thing's bad. And then I kind of went on to say, in my opinion, tRPC is like first gear. It's super easy to get going with, and it'll get you up to speed real quick. When you need to shift into a higher gear or for mobile third-party API, you start thinking about data design again. And in essence, support a version REST API for that. I go on to say that GraphQL is kind of like getting started in third gear. It needs a bit more oomph to get started with, but it might take you a bit further in the end. And so apparently those were some real fighting words. And these two just wanted to get into it even more after that. So anyway, without further ado, I want to introduce Alex from tRPC. Alex, you can come right in. Woo, Alex! High five. Good to have you. So Alex is joining us all the way from Malmo, Sweden. And then, of course, we have Phil. Phil from the urql project. Phil, come on in. Woo! High five. And so Phil's joining us from the far depths of Deptford, London. And so without further ado, let's get started. Hope you all enjoy. So just to get a feel of the room right now, so this is really about all of you and the folks up on stage have a discussion together. It's not just them talking. It's not like I'm purposefully a facilitator, not a moderator. I'm not here to moderate them. I'm here to facilitate discussion with all of you. So feel free to ask questions or thoughts or anything. Don't feel shy to just jump right in. We're here really because of everyone that's here today to ask questions and be involved in the discussion. Just so we know, before we get into things, how many of you are using tRPC right now? So just put your hand up. Okay. Then how many of you are using GraphQL right now? Okay, so that's 100% of the room's using GraphQL, and nobody's using tRPC. So you can just go back to Sweden, Alex. I'm so sorry. Well, thank you so much. Thank you, Prisma, for hosting, and have a good night, everyone. Okay, cheers. And so before we get into things, I'm wondering if maybe Alex, you can tell us a bit more about what tRPC is.
Yeah. So no one was using tRPC, but how many people know what tRPC is? Most. Okay, cool. So in essence, if you want to boil it down, is tRPC, instead of writing a bunch of like API specs or whatever, you write functions on your server, and then you can call them on your client as if you're part of the same system. And you can get like jump to definition in a client-side call, and you jump straight into the backend definition where that function is declared. And then there's a bunch of more stuff to it as well. It's like a pretty full-fledged backend framework, but we can get into more of the depths later.
So it's a way to call a kind of a back-end function from your client, basically.
Yeah, and the T stands for TAS. No, TypeScript. So it sort of relies on you having TypeScript on both ends, which obviously everyone doesn't have, but...
I mean, my initials are TS for Taz Singh, right? And so, yeah. Anyway, cool. Well, thanks, Alex. And then so, Phil, can you tell us about, I guess, GraphQL and, of course, your project urql?
All right. Well, I hope GraphQL doesn't need too much of an introduction. But if you're not familiar with it yet, it's a language-agnostic way of querying your data and modeling your data on the back end. It's pretty opinionated, I would say, but includes the best practices that most people would probably reach for, hopefully. So it's self-documenting, and it's also pretty product-centric. So whatever you're building, you're probably building something that is used across several apps, but in a very similar way to kind of use it across multiple teams, maybe. To speak just a little bit about urql, urql is probably more relevant today because it can be compared more to tRPC in that it mainly is written for and in TypeScript to basically query a GraphQL API on the front end. Keep it short.
Yeah, I mean, yeah, we can get into more, and so we will. Cool. Well, so you've been working on urql now for how long, Phil? I think it's 4 years, 3 years.
I never counted.
And then tRPC for...
I think it's probably exactly 2 years to date or something like that. I know it was January 2 years ago. So
Is it tRPC's birthday today and you didn't even tell us?
it might be.
Wow, okay,
I should check the Git commit history, but around 2 years ago I started with it. Yeah.
Well, we're just going to say it's today.
Yeah.
So happy birthday, tRPC. Wow, well, congratulations. That's awesome. So it could be urql's birthday today too, but who knows? Like it's certainly Phil doesn't know. That's awesome. So yeah, tRPC is certainly a bit of a younger project than GraphQL, and I think what you've used GraphQL in the past, was that part of your inspiration for creating tRPC?
Yeah. So like I started using GraphQL maybe 2016. Can that be right? And for me, like first time I looked at GraphQL and tried it, it was like the holy grail for me. Like it felt like most of my problems that I've ever had with API communication just like could be diminished from that day on. And then I used it for 5 years, didn't have much of an issue with it, and it wasn't until I started my own company and I was doing this like pretty complex marketplace application, and I was only really having one consumer on the front end, and then I had a GraphQL backend because that's what I usually do. And I just felt like there should be an easier way of doing things because I was using TypeScript on both ends anyway. So why can't I just like declare a function and use that function in the front end? And started looking around for solutions, and yeah, didn't really find anything that satisfied me, so I built it.
Nice. And so I guess that introduces kind of an interesting topic there, which is you're building for yourself in your own monorepo with TypeScript on both sides.
Yeah.
And I think that's kind of the kind of essence of where tRPC makes a ton of sense. Is that right?
Yeah. Totally agree with that sentiment. Yeah.
Oh, okay, cool.
We're done.
I'm guessing a lot of people fit into that category. Like I've spoken to a lot of folks myself, and they ask me, hey Taz, like should I use GraphQL? I tell them actually tRPC might be a better use case for you if you're building kind of like that. So my understanding is with GraphQL you found yourself encumbered by writing a schema, having kind of client-side concerns and to query it? What sort of encumbrances did you see with GraphQL that kind of made tRPC an obvious choice?
Well, one of the parts is like as soon as you're using GraphQL, you're bringing in another language and another barrier. So you have to have like GraphQL queries that then get sort of translated into TypeScript. Was really big on TypeScript back then as well. But it's that extra layer where you have to have code generation, you have to write pretty complex like a backend logic to fulfill your queries, and then you have to write the query on the front end, and then you need to have a lot of tooling around it to get the code generation to work, make sure that all of your like page is actually loaded in one beautiful query as you want. And it takes a lot of work, and it's hard to set up. And yeah, I just felt like it got in the way of me just wanting to ship fast with confidence.
It's a complicated thing to answer to, but I think the interesting comparison comes when I'm looking at tRPC and the TypeScript part, obviously. Because I think when we're talking about GraphQL, we're talking about a lot of different things, a lot of different tools. Because GraphQL is a specification, it's not a single library. And that means that we have a lot of options, a lot of things to choose from. So when we're starting an app, we have to make a lot of decisions up front. We have to have some kind of idea of how we want to build an API. We have to not only model our data, but we have to think about, okay, how do I get started? What kind of experience do I want? And I think, especially I think in the recent 1 or 2 years, people have kind of started feeling a bit of GraphQL fatigue. And the conversation I've seen is that a lot of people are not willing to set these tools up anymore. And part of that is because there's so many. So I think maybe, correct me if I'm wrong, 3 years ago, for instance, when you're first working on tRPC, what it was likely like was that it was hard to get all these tools set up. I would say if I was actually talking about tRPC today, the interesting thing is that GraphQL is in a perpetual state of being not quite ready for a certain type of person. And when you're specifically talking about TypeScript, right now the tooling is not as polished as tRPC, just by virtue of there being a lot of choices they have to make and the tools just being widespread. So for instance, I don't want to say anything negative about it because that's one of the tools that we don't have a good alternative for, but GraphQL Code Generator is a complex, big thing to set up. You can set it up to generate code for you, as the name implies, but what you would likely generate with it types for your queries or entire hooks. And that's kind of how you get a nice experience on GraphQL. But admittedly, it's not as fully fleshed out and integrated as tRPC. So the only note I'd have is that you can get a nice development experience in GraphQL through various tools, be that with Relay's code gen or GraphQL Code Generator's code gen, but mostly your options there are quite limited.
Yeah, it's kind of like you need to do it yourself. You need to set it all up yourself. While tRPC is just kind of it's kind of done, right? So it's one of those things where I'm often hit with this term like unopinionated, right? And so if it's unopinionated, that means you need to bring the opinions in a lot of ways. And so like GraphQL Code Generator seems a bit unopinionated, and that you need to plug it in as you want to set it up. But it might be a bit tricky for you to do so. While I think tRPC just provides the opinions out of the box. You need to be TypeScript both sides, monorepo, et cetera, et cetera. Those are a lot of opinions that you're kind of putting onto the user, but it just kind of works in that setup, which I think is kind of interesting. Yeah, we got a question from the back.
Hey, so when you talk about developer experience, I found that the introspection system in GraphQL really helps with building tooling. So I'm wondering with tRPC, is there any system like that embedded into it?
So introspection tooling was the question about. So in GraphQL, you can introspect your API and easily get a documented view of everything. And the question is, do you have something similar in tRPC? And the answer there is that there's some third-party tooling to provide that. There's a project called tRPC Playground. That's one of the core contributors of tRPC has worked on. That gives you sort of like the graphical version of tRPC. And then secondly, there's a new project called tRPC Panel, where you can get a documented sort of swagger looking thing for tRPC. But you can obviously only get that for all the sort of endpoints or procedures, path functions, whatever you want to call them. And the input types, the output types are sort of not declared in that spec. They're there in TypeScript, and TypeScript sort of provides the API schema for you. But unless you do a lot of introspection work of the AST of TypeScript, you don't get the output types. Did that answer the question?
Yes, thank you.
Yeah.
That kind of brought up a question for me, which is if in tRPC you just return an object and that kind of gets given to your front end, Does that make it easier to leak data across boundaries?
Yeah, so that is one of the things I do miss from GraphQL, this sort of like safe data transfer object. So in GraphQL, you can do field-based authorization and make sure that you don't like accidentally return a password, where in tRPC, you can do a select star from a table and potentially leak some sensitive data to the front end that you don't want to. And the only way to see that is by introspecting the actual types within TypeScript. And that is one issue that we're currently working on providing solutions for. The thing you can do today is that you can enforce an output schema when you declare a procedure. It slows you down a bit because you then have to obviously type out like exactly what you're returning on each endpoint like you would do in REST. But it's possible to make that safe as well.
Cool. Interesting. You have a question? Yeah.
So, as a beginner who has gotten extensive experience in duck type languages like JavaScript and PHP. Okay, I didn't mention PHP. Okay, so JavaScript is like completely type-free, and I love it that way. And due to the nature of the whole JavaScript environment, I'm going inside TypeScript and GraphQL. So I had a bit of struggle to get along with TypeScript and GraphQL. So how about the learning curve for both the things, urql and how's the support like?
Do you want to start? Or?
I can start, sure.
Yeah.
I think GraphQL is interesting. We still get a lot of issues from people who are just using it with JavaScript. And I'm not going to lie, in some sense, TypeScript gives you a better experience and maybe a tougher experience if you're new to it, because it's an extra thing to learn. And I think GraphQL is luckily a bit less to learn if you're ignoring all the tools I've talked about. It can be challenging, but once you've chosen a tool and once you've chosen to build a GraphQL API, I think it's a good compromise. If you don't want to go full TypeScript on your app, then there's not much you have to worry about if what most of your app is doing is probably just rendering the data. Because at least assuming if you're writing some tests for it, it still renders, then at least you can look at it and just rendering data is going to be minimally typed just through GraphQL.
And on the tRPC side of that, like obviously TypeScript is in the name of tRPC. So if you're not using TypeScript, tRPC becomes kind of pointless. However, one thing that is quite nice with tRPC, especially in combination with a typesafe or ORM like Prisma, is that if you look at like a big router where you do a bunch of queries, you will actually see that you're not writing any TypeScript in that file, because the Prisma, when you write a query, will be automatically typesafe for you. You select something, you get that exact object returned, and then you return that to the client, and then you use that. So you get sort of like all the benefits of TypeScript without the work of having like declare all the types and all of that. And I think that's the best things for beginners that are getting into tRPC, is that 99% of the code you write is just JavaScript, but you get that extra safety of TypeScript and the auto-completion and all of that nice stuff.
And comparing to GraphQL, how much supportive is tRPC? Because GraphQL, there are like loads and loads of libraries, right? So how's the support with tRPC? Because I have never heard of this. Is the first day I'm hearing that.
Yeah. So the question is about how's the support of tRPC? So
like for example, I'm working with React and Node.js. So I'm pretty sure it will be compatible. So how about in other languages and other?
Okay, so the question is about tRPC in other languages, and the biggest answer, the main answer there is that you will lose a lot of the benefit if you're not using TypeScript on both ends. There are plugins to generate like Swagger schemas based on your tRPC backend, but you don't get that like the same rapid development as you would do if you had it all in the same monorepo.
Actually, my last company used GraphQL, and currently in my own project, I use tRPC. That comes to common sense. I think Tess just mentioned that tRPC is good for the monorepo and maybe for personal project. And but I'm thinking, well, I'm in China, so I think 99% Chinese companies, they are still multi-repo. And but from my side, I think still tRPC could benefit we could benefit from tRPC because still GraphQL is has some threshold to use it correctly. So I'm wondering, does Alex consider to make some support for the multi-repo? Maybe like the upload GraphQL server, you can just expose the endpoint, and the client just to retrieve the type definition automatically or pre-build to get the type definition to the client, and you can just still get the type safety. Or maybe you can even go further, like build your own called the TIDO file, if you know what I mean. Yeah. So I think that's one difference between the GraphQL and tRPC, because GraphQL has a schema. So in that case, I think if you have schema, then a lot of things could happen in the future. Yeah.
So the question was in regards to monorepos and tRPC, if tRPC can work outside of monorepos. And it can already today, and there's a bunch of companies that use it that way. And the way they do it is that they sort of publish an NPM package of their server types and then import that as a package. So you have like a private NPM repository where you have your server types, and then you can use it across repositories. But it's not
It's a little troublesome, yes.
Yeah, it's a bit troublesome because also then you like the nice thing and the bad thing with tRPC is that it couples your front end and the back end. You can argue that all day if that's a good thing or not. But as soon as you like diverge where the source of truth is and you don't have it in the same place, there's risk of breaking stuff on the client because you do a change that is not synced on both ends.
I think we should focus a little bit more on how actually tRPC and GraphQL are used. And so for that, I usually, like essentially when I'm looking at an application, I look at essentially what they call a master detail type of view. And so I'm kind of drawing it out here. But if you can think of like your average contacts type of UI, we have a bunch of people on the left, and think of that as like a list that's kind of like infinite scroll. On the right, you can kind of get the detail of each and every single one of those. So in this case, like, for example, if I'm looking at Alex, it might be like, I don't know, Alex J, from tRPC, if I can spell, yada, yada, yada. And so the reason why I like this type of example is because, in my opinion, what we do as UI developers, 90% of the time we put data into lists, and we kind of need to get those lists to paginate. And the other 90, and the other part of that, we kind of take the data from a form. And so if we can do kind of forms and lists and kind of put data from a form into a list and data from a list into a form and vice versa, that's like the majority of the complicated interactions that we need to deal with, day to day, is kind of, some sort of variation of that. And so in this type of perspective, I'm just kind of curious, how does GraphQL do it? How would tRPC do it? And I understand GraphQL might do it a few different ways. And so I'm wondering, if you could just walk us through, like how would that actually work with GraphQL? So I guess to provide a bit more definition to the question, let's say I'm in here and I'm saying Alex, and then I want to type in Johansson and the rest of his name, yada, yada, yada. There's a little submit button down here. Submit, save. I can't write. I'm better at typing. I'm terrible at writing. So let's say I type in the rest of his last name and hit the save button. That would update in the side here. What would that look like in GraphQL?
I think I want to first zoom out just a little bit, just in case, which is that the biggest difference we obviously haven't touched on yet is the literal queries that you write in GraphQL. And every single view or component, however you want to structure it, defines the fields it wants, which are relational. So in this case, we might be querying a list of people. We have their names, we have maybe their occupation. And we're saying, okay, in this example, we're trying to edit that. And I think from a GraphQL perspective, when we're talking about queries and mutations, we're talking a lot about defining data, defining dependencies of data, assuming you've already written the API, of course. And then we're describing how that data changes. Very basic. Whereas I think we've talked a lot, especially in the last few minutes with tRPC, about writing the code that does that. And I think the emphasis on the data itself is quite interesting because tRPC works so well because it's a nice workflow. And it's trying to make that workflow of writing the code, of changing things simpler. And I think in GraphQL, it's helpful to zoom out a bit in that we're often describing what data we want and how we want to change it. And that can have certain benefits because a library like urql, relay, Apollo can go in and make certain assumptions about what you're trying to do as a UI developer, for instance. So in this case, when we're writing these queries and you're trying to change that data, normalized caches are pretty popular in GraphQL because in GraphQL, we're describing so much data, and when that data changes, we can update the entire UI, all the views automatically.
So just to say it back in a different way, what you'd say is like kind of like this here, for example. I'll just highlight this. This would be kind of like one query.
Yeah.
And this would be like another query here.
Yeah, and then you click save, and we're sending off a mutation. Let's say we're changing your name. Sorry, you're not called Alex anymore. You could be called Tom. I don't know. And then the other query would also update to Tom. And I think the interesting thing about that is not the mechanism of how that is working. You can implement that in any state management solution, as many have come before. Or you could just load the data again. But I think the interesting thing about GraphQL is if we're writing an app and we're using some data, we can make some assumptions about what data is shared between different views. And I guess it's pretty interesting to talk about that from tRPC standpoint as well.
Yeah. So in tRPC, this view would probably be two different queries. So you would have a list query on the left there, and then you would have a by ID query there that you conditionally use based on if you've selected an ID or not. So that's quite easy. And then when you do the mutations, we don't have a normalized cache in tRPC in the same way because queries is just like endpoint blob of data. So we can cache the sort of like endpoint relationship to data, but we can't say like when I change Alex to what did you use, Tom? I won't be able to update that list view like automatically like you can do in GraphQL.
So so yeah, just to colorize that again, because again, I'm not sure how many of us are familiar with all these intricate details of all these different libraries. But basically, in GraphQL, like this would be, oh geez, that's not what I wanted. If I undo that, this would be like a fragment here, and then this would be a separate fragment here, and that would be a separate fragment there. And so when you hit save here, so when this happens, this would particularly update that fragment inside the normalized cache. That's kind of what, at least I understand that's basically what you're saying?
Yes.
And then with tRPC, as you're saying, the same save button here would update kind of this here as well as this entire list. So it would update kind of the yellow and the green?
I mean, by default, it wouldn't update anything. The mutation does, like, there's no relationship as default, like between queries and mutations. There's no knowledge of that data. So you hit that mutation, you save, and you get no feedback.
Like nothing would happen.
Yeah, but that's not the way I work with tRPC myself. The way I work with tRPC is that when I do any mutation in my app, I usually invalidate the full cache on the front end as part of...
Would that just make the whole thing be a loading spinner then?
Yeah, so then you would have a save button, and the save button would have a loading spinner until we have fired off the mutation, gotten a response, done another query to refetch the data on that you're currently looking at, and then the loading spinner would disappear. And yeah, so it would be more similar to how a traditional web page would work, where you submit a form and you go to a new page, but it feels like an SBA and it's a bit snappier.
So you would just to say it again, this would be a loading spinner here, like this would be a little loading spinner there. Like that loading spinner would then in the background like make the mutation to a server. It would then like that would like positively come back, successfully come back to the client. The client would then say, oh, okay, all my data that's currently mounted is invalidated. Because you basically told your client to invalidate everything. So basically it would say, I know this here is stale, this is stale, like all of this is stale. It would make another batch query to the server then to update all of that because it knows this is what's currently mounted on my page. And then that batch query would come back and update everything.
Yeah, so that's an important note too. Like similar to GraphQL, tRPC has the notion of batching. So if you do several queries or mutations at the same time, they will actually be popped over in the same request. So it might sound slow to do that, but it's how the web used to work, first of all. And also it only does one request to the server, so it's not that heavy on the server either. And the benefit GraphQL is that you don't need that extra request. As part of the mutation, you can return the data you want, and it will smartly update the page. But you get sort of similar UX feel by invalidating everything. And in those 100 milliseconds or two might not matter to you.
Yeah, so in GraphQL would be one operation. That save button would update both of those things in one shot, basically based on the normalized caching that Phil's mentioning.
Yeah, I would argue it's interesting to look at normalized caching. There's also nothing wrong with having state management with tRPC. I'm sure we could talk about the technical intricacies of, this UI updates in a certain way when we click save. I think the big difference is that in GraphQL, you have the potential to get a lot of this for free, a lot of user experience and a lot of mechanisms that we would expect from a modern web app. I think where it goes a step further is, and this is what I mentioned at the beginning, I think GraphQL is in a perpetual state of almost ready, in that we're for some people, it would look like we're doing very convoluted things just to get basically a JavaScript object in this case. I think there's a bit more in that we have a query language and we're describing what data we want, but there's more coming in the future. And I think the most interesting part is that GraphQL is changing, for instance, how you could load data. And there's something called the defer directive, the defer proposal. And I think that is a proposal that when I've shown it to people, it really their eyes about what GraphQL could be used for. So that proposal, you could mark one of these fragments or some data as deferred, meaning that you tell your GraphQL API, I don't care about this data yet, but I would like it in the future. So in this example, for instance, you could defer individual parts of this view. You could say, this query on the left is deferred, so you want to render the main screen first, main content of Alex, you want to display that. And then the server goes ahead and sends you the rest of the data later. And then you could add that on. The nice thing about that is that GraphQL can basically move in this direction and offer pretty powerful features just by adding a single word to the query language. And I think that has a lot of potential. You can basically describe in natural language how you want your data to be delivered and what kind of data you need. And I think GraphQL clients doing a lot of that automatically can basically save you a lot of time if you kind of need these smart features. I think what you've talked about with loading the entire view gets us into a different territory. We're talking about the loading pattern, we might talk about static site generation, and we're starting to talk about pages again. And there is a middle ground here between full web apps and pages. And I think there's a bit of nuance in there, and it becomes harder to tell, should I use GraphQL? Or if you're just building one app and it's really simple, should I just go for tRPC and save myself a bunch of time? But I think it becomes more complicated when you go to more complex apps.
Yeah, and I guess we'll dive into that a bit more in a little bit. So apologies for halting questions for a bit.
I'm a bit slow, so I have like 10 questions, but I'll only ask one for now, and if it gets dry later.
You only get one sticker.
So one of my many questions is, in this theoretical example, if I'm using tRPC, could I just write a function where it just does when I update something, it just does a select something where ID equals Alex's ID and just returns that, and then if depending on how I'm managing my state, I can just kind of update just that slice myself, or would it be how complex would it be to implement that kind of behavior yourself?
So if I understand the question correctly, it's about granular state updates, right?
Yeah.
And so in tRPC, when you're using it in React, it's built on top of React query or TanStack query. And with that, it's sort of React query on steroids because you get additional type safety. You know the shapes of everything in your cache. So you can stick into the cache and update a specific thing. So you can do things like optimistic updates and stuff like that. But it's not as magical as GraphQL in the sense that there's no connection between two different queries. Did that answer your question?
Kind of. I mean, the optimistic update part did, and I was wondering about kind of the basic, actually how to query and stuff. But you could still have a function that just does a database query just.
Oh yes, yeah. You can just do like a function that does a Prisma query, return that data, and then you just use that data in the client.
Yeah, so like this green view on the right could be one of those, for example, where it's just like Alex by ID, you know what I mean, and then it just returns that data object for him. And so I think that's one of the beauties of tRPC is that because of that tight coupling from the server to client, you have that exact same type that you're working with on the server. That exact same type is now on the client. And so if you type in like alex.birthday, you know what I mean, that won't happen because it's just not even loaded from the server. And so that'll just be a red squiggly line for you on the client, and because it's not even there. And so you're like, oh, okay, I should probably load that from the server. And then you go to the server, you add that birthday field, and then bam, now it's there on the client. And so like it's that kind of beauty and ease and simplicity of just server giving you whatever you need to the client without writing a schema, without any of that kind of ceremony of defining which type it is. Is it nullable, non-nullable?
Yeah.
Like who even knows? Do I need another type for that? Do I need a date type for that? I don't even know.
And
it's just kind of all done for you now.
And that birthday type can be a date or a temporal plain date, and it can automatically get serialized and deserialized over the wire in a bit easier way than in GraphQL you would use scalars instead. So you can like do very complex objects, just return them to the front end and use them as if you're calling a function server to server.
Both the things have the same number of queries or like HTTP queries or?
No, so that's a great question. So the tRPC example, as Alex mentioned, is technically 2 HTTP calls. It's one to make the mutation and then one to do the batching update. With the GraphQL, if you're using a normalized cache, it's one. If you're using a document-based cache, it would also be 2 or n queries, basically?
It depends, yes. At least in urql by default, we have a very similar cache strategy, which is just invalidate the data, load again. And bringing up tanstack/react query is quite interesting because it basically talks about the part of integrating something like tRPC or something like a data layer with your front-end framework. And there's a lot to be said about that, but I think anecdotally, I hear a lot about tanstack query because people are talking about, okay, why would I use urql instead of just using tanstack query with GraphQL?
Well, it's funny you say that because I think Alex told me something very interesting the other day, which was, and I'm gonna say it in my best Alex voice, which is that if you're using React query with GraphQL, you're using GraphQL wrong.
Yeah. It's like you miss a lot of the like power features of GraphQL. Like also, everything Taz said in the beginning is a lie. I love GraphQL as well, but like GraphQL is amazing, and like the way the data is structured is amazing. It has a lot of niceties with it, like having the ability to have a more normalized cache and be really smart and doing really pretty optimistic updates in a very cool way. And if you're using React Query, you're basically treating your GraphQL as a REST API. And sort of like I think you're doing yourself a massive disservice by using React Query instead of something like urql that is specifically designed and leverages a lot of the amazing things with GraphQL with it.
Yeah, it's kind of like make your own endpoint. So you're kind of looking at GraphQL as a way to carve out your own endpoint, as opposed to, I guess, what Phil has talked a lot about, which is normalized caching and kind of the benefits of having a consistent UI that kind of updates itself well. However, I can understand, of course, that there's more barriers to kind of that approach, right, than something simpler where the paradigm is simpler, not specifically the tool, but the paradigm is simpler to think about, where like GraphQL and React Query, for example, is a simpler paradigm to comprehend. And I guess that's where tRPC really shines, is really making that paradigm work well, while I guess to your point, making it work with React Query, GraphQL might be a bit of kind of a missed opportunity there in a way. Yeah. But yeah, sorry, I know we have a few more questions from the audience. So I know you've had a question for a little while now.
Yes, so we've got two people kind of at once. Very confusing. So in React application, there's a quite common, I guess, almost anti-pattern more than pattern. We often will have a component that's doing some kind of fetch, and that fetch is finished. And now it's got some more components which will do some fetches, then they'll later, which will do some fetches, and the whole thing kind of waterfalls through in this really ugly way. With urql, in our company, we've managed to find a nice way of still having the components define what it is that they want, but those are all defined in fragments, which will then get code gened up into one nice query at the top. We get to do that at exactly when we want to do it, so with exactly the number of loads we want, and it all runs up wonderfully. How would I solve a similar problem with tRPC?
Yeah, so the question is about query waterfalls and how you can avoid that with tRPC. And there's not like a simple silver bullet answer for that, but generally speaking, when you're looking at the page, you're looking in general at a specific ID. So as long as you do like the queries further up the React tree and all of the different queries, like maybe you have a post by ID and then you get like comments by post ID, as long as they're further up the tree and don't like conditionally render, and which will trigger a waterfall, you can get similar behavior. But this is sort of like one of the cases where GraphQL really shines, because you can have this like infinitely nested application where you don't really know what's below you in the tree, and you just grab the fragments dynamically, and being able to do this like one beautiful query to fetch everything in your front end.
I'm glad I don't have to bring it up. So basically, the thing I love about GraphQL is that we're building a tree of relational data, and then we're saying, I want these parts of that tree. And it mirrors itself so nicely to how we're building apps today with components. And when we're building a React app or Vue app or whichever framework, you're basically building a tree of elements, a tree of things you're displaying, and every component needs a different amount of data, different fields. You might have an avatar that displays an image, and it needs to have a URL. That might be inside a user component, which displays a name as well, so now it needs the name. And that might be nested, who knows, 5, 10, 20 levels deep. And I think before GraphQL, the problem I heard about again and again was prop drilling. And ever since more and more people use GraphQL, we talk about it a lot less. Because how I see it is in prop drilling, where we were annoyed that we have to pass data down from the top of our components 30 levels down to components that are just rendering some text. The problem with that was, in my opinion, not that we're passing on data, but we had to mentally keep track of why we need that data. We might be halfway down the tree and we're talking about a user, and we're only passing on the user because 5 more components down, we need to display that avatar image. And with GraphQL, we have a nice way of composing the fragments and saying, okay, data flows down. I know what I need to pass on. Now we have this entire tree of data and tree of components and matches up nicely. And we're not as worried about prop drilling as much, I hope at least.
Is this something that you've written a blog post about, perhaps?
It is.
Oh, wow. It is. Oh, wow. Do you have this nicely diagrammed in that blog post as well?
I do.
Oh, wow.
I do.
Amazing. I guess we'll post that somewhere if you just search for what Phil plugged in urql.
If anyone's curious about a blog post about this topic and normalized caching, you can go to kitten, like the cat.sh, and you'll find my blog with that exact post. And I think the difference is in what we talked about. The nuance here really is about whether we're talking about pages or we're talking about components. And while I love loader patterns for their simplicity, and I've used them, I still use simple pages that get data every single day with a lot of apps I'm building. There is a slight nuance to it once we're bringing in components and having this kind of complexity taken away from us, of being able to not having to decide up front of when do we load this data, when do we query this data, and instead thinking more about fragments being put into a query, and we're loading that all at once, but I can reuse that component and split back out if I need to. And I think it's not like that there's some huge drama here and tRPC can't do that. But I think that's the point where in tRPC you need to make a decision of how do I load that data and where do I put it? Because you do have to then make that decision of, do I pass the data down into that component, or do I make a separate query which sends off another request? And how far do I go?
Depends a bit, like you can for instance, if you can have a very niche component and use a query in that, and as long as you already queried that somewhere else, you won't query it again, right?
Yeah.
So as long as you make sure that everything on the top of the page, yeah, now we're talking about pages again, has fetched that already, you can safely use that query. But to your point, I fully agree that it is very nice to be able to think about components and their data requirements as a sort of pure concept.
Yeah, I think if we're thinking back about our example, because I still have it here, let's say we have this page, we have a name there, we have an occupation, and we want to add an avatar URL. Yeah, why not? All right, let's say I want to add something new to this page.
It's a good thing Phil is much better at drawing than I am.
Yeah, but there's no space here. But let's say we want to add an image here. Of,
You can zoom out a little bit.
let's say we want to add something here. I want to add an image. This is Alex.
Oh, wow, it looks just like him.
Yeah, I know, right? So now we need some new data. So let's say we have 3 pieces of data here. We have a name. I'm left-handed, so I think it doesn't like this. And then it had the occupation. I'm not going to write this out. It doesn't really matter. And now we're adding some new data here. You can... That was interesting. See, now this is coming back to haunt me. I told Taz, use FigJam.
You can press the undo button, maybe.
Oh, I mean, I kind of managed. Right, so we're adding some new data here, and that is a new field. I think what we're talking about is we want to add an avatar image here. We can just add an image URL to our user. So all of these 3 things are on an object that we might call a user. And that's on R. Anyway, on the back end, we have some kind of type and some kind of object that we call a user. If we just add something new to that, it's going to be everywhere where we have a user. That applies to tRPC, to GraphQL, to anything. I think the difference is that over time, we're obviously adding more and more fields, and we might want to be more specific. And what I'm talking about is in tRPC, you have to make a decision. You have to either make a new object with just the data you need, or you can just, well, I guess just add the field, and then you have the data. And I think the difference here is subtle, but after a while, you obviously have to make more and more of these decisions. And I'm not going to speak against that because I think GraphQL, like tRPC, can get messy and allows you to get exceptionally messy without any consequence because you still have the types in tRPC, you still have the schema in GraphQL. And I have to admit, when I write a GraphQL API, half of the resolvers are shit. It's shit code. No one needs to talk about that. It queries some data, it returns some data. It doesn't need to be perfect. And I think embracing that kind of mess is good. But I think when people think about that, it comes with a lot more ceremony in GraphQL, adding in the field and querying that. And I think the trade-off is obviously in tRPC, the question becomes how long can you go on? How long can you keep changing things until you need to refactor? Yeah. But what is your approach to that when you're talking to people about bigger apps, when they get to that point?
It's a good question. So I thought when I started when I started...
Get out of your hands.
Thank you.
When I started using tRPC myself, I thought I would be way more bothered about like the whole like overfetching, underfetching problem that GraphQL so elegantly solves. But the fact that I have fatter results doesn't really matter up to a certain point, right?
Yeah.
And when I hit that point, it's sort of like I don't have like strict guidelines on what that threshold is or any rules for myself, but you sort of know, right? Like if you querying a piece of data that returns 100 fields and you're only using one, maybe you should do a bespoke procedure or think about how you can break that procedures out into multiple procedures, because you can still, as long as they have a common denominator, which is an ID, you can still query them all at once at the same page and get them batched together. So it's a very different like mental model on how you do it, and it's more stupid
It's more coupled. I would like the way I would think about it is more coupled, right? So the way I think about GraphQL, it's often more around data modeling. Like I think, as Phil mentioned, I'd add these fields to a user object. You know what I mean? That is data modeling, right? Fundamentally, I'm modeling my user object. And if I was thinking in tRPC, I wouldn't even think about any of that. I would just literally return one thing for one view I'm building, and I'd build another endpoint for another view I'm building, right? And like maybe that's a way of doing it, right? But I think the key thing that basically I feel is that there's less ceremony. It's not like I care in tRPC. I just return the thing and I use the thing and I'm done. You know, that's it. I feel like with GraphQL, there's a bit more ceremony. Again, going back to that analogy I said earlier, it's kind of like starting in third gear, right? It requires more oomph, but third gear will take you a bit further than first gear, right? With tRPC, I just put the thing out and I'm done. You know what I mean? And I get going and I build a thing and I keep iterating and that's it. That might be a bit of a crude way of saying it, but in very simplistic ways, that's the way I think about it, at least.
Yeah, there's something there. I would also add.
He's being kind.
I would also add, like, there's a huge power in like never have to have a conversation about like API design. Like, I've been working on a team of almost 10 people now for a year. And we never had a single discussion about like, this is how our API contracts look like, and sat around talking about that, or how pagination works, or whatever. Obviously use cursor-based pagination, but there's a lot of considerations there. When you design a GraphQL schema, you are designing for your future self way more, and tRPC is about designing for now. And it's sort of like you can move really fast with designing for now.
I mean, like I would say that a bit differently. It's like when I design a GraphQL API, I design for someone else. Like I design for myself, but also for someone else. You know what I mean? When I'm working with tRPC, I'm really like designing for myself. You know, that's the way I think about it. Yeah. But anyway, I know we had a few other questions from the audience. So I think Yanni, you've had a question for a while.
Yeah, so if I can slightly simplify, the trade-offs are that with tRPC, you get this really nice authoring experience, like it's very slick and easy to get going, but then the trade-off is that, like you're kind of highly coupled and you're stuck with that kind of like one monorepo, one app, paradigm. On GraphQL, it is the opposite, right? Like, you get all this power and, whatnot, but at the same time, you have the ceremony and the complexity of the tooling. So Phil, what can GraphQL do? Like, can we write a more opinionated GraphQL client experience that approximates as good as tRPC is? And Alex, can tRPC provide anything on the backend to sort of like push further into the sort of like multi-purpose backend thing? Like, is there a middle ground here?
You can start.
I think.
And repeat the question because it was long.
So tRPC has a very nice experience, and you can kind of only get so far, and on the other way around on GraphQL, you can get pretty far, but the experience is not as nice. TLDR. It's not that nuanced, I mean, as you put it, but I think, long story short, at least what I want to work on with urql, what we want to work on and where we want to get to is that kind of experience. You shouldn't have to choose between these two things. You should have a nice experience and should be able to get pretty far. Because I think that was the promise of GraphQL. And it's whenever you talk about GraphQL, you eventually get back to talking about over and under fetching. You eventually always talk about, with GraphQL, you're so efficient, you can optimize performance. And maybe the performance is not that good, is what people argue about when they talk about GraphQL. But you don't have to care about how much data you query because you're never overfetching. You only get these fields. And I think that's a terrible sales pitch for GraphQL, because you can just remove a field in tRPC and you're done. You can just remove a field from your JSON response and you're done. I think we're talking about a lot of technical things when we're trying to sell GraphQL to people. And I think, if I'm hopefully not wrong, a lot of people here in the room, when they first heard about GraphQL, the first thing they heard was probably about how efficient it is when we're sending this data around. But I think this kind of vision of tooling can be better because of GraphQL, and we can build better GraphQL clients that have that tRPC experience, and they can do these powerful things where we can defer parts of the data, where we can express what data we want. I think that is the goal, where we want to get to. And the closest you can be to that today is with Relay. And you're still stuck with a bit of ceremony and a lot of learning, and there is still a long way to go in improving that. And that's, I think if I want to say it for the third time, GraphQL is in a perpetual state of not being ready, but at least it's pretty powerful if you put in the time.
But Phil, you're so smart. Why haven't you solved it?
I'm also lazy.
I want to repeat the question. The question was, Phil, you're so smart. Why haven't you solved it? For those of you online.
I'm lazy.
And the answer was that he's lazy.
I think that the problem with GraphQL is a lot of people are working GraphQL and it's targeting a lot of languages. You can write GraphQL for a lot of different languages on the backend. You're using it for native apps, which is something we haven't touched on. In React Native, you can certainly use tRPC. But if you're writing an app for iOS or Android, for instance, then GraphQL is a good option.
Yeah.
And tRPC is likely not available if you're using Swift or Kotlin, for instance. We can get into these small details, but today we're talking about just the client. And I think the interesting thing is just that in the past, so many projects existed for GraphQL, and still we're working on so many different things that there's a lot of people of a limited amount. Maybe, personally, I know probably 30 people working on GraphQL projects. They're all split doing different things. And I could obviously selfishly say, they should all be working on urql and the things I want to work on. But the reality of it is GraphQL is just maybe a bit too ambitious for its own good, and there's too much to do.
And the question for me was sort of, can I just make tRPC continue being as nice of DX, but make it do everything GraphQL does?
Not everything.
But most things, I've gotten requests about field level selections, so you can do subqueries and stuff like that. And it's just no, that's not the goal of tRPC. If I wanted that, I would focus all my efforts on GraphQL instead. So when people ask for things like that, it's that's a requirement, use GraphQL. The power in tRPC. And also, I'm not smart enough to do that. And the power of tRPC is the simplicity. It is that you just you have a function, you send input, you get output, and that is the beauty of it. And then there might be the case for some companies, people, whatever, that grow out of that eventually, and then you can copy paste all of your resolver logic into a GraphQL server.
Cool, awesome. I think there was another question back there. Yeah.
So one of the areas that RPCs have typically been stronger in has been where there's real-time kind of server-originated events. For Phil, what do you think the current state of server-side push or WebSockets is for GraphQL, subscriptions, that kind of stuff? And for Alex, how does tRPC look in that role?
Yeah, so real-time communication with tRPC versus GraphQL. So in tRPC, we have subscription support. So WebSockets and subscriptions. It's not as nice as the DX of the query and the mutations. The main reason for that is that I don't use it myself. So I haven't spent massive amounts of effort to making it perfect. And it's only also limited to WebSockets right now. We don't have server-side events. But it does work, and it's quite efficient. It's not the most minimized payload that you can possibly get, so it's probably not suitable for gaming or something like that. But it works pretty well for a chat client. Did that answer it?
Yeah, I think so. So with tRPC, you can kind of make a call, and that call is an event.
Yeah. You can have you return an observer on the backend basically, and you push stuff to that observer, and that magically comes over to the front end in another observer.
To kind of continue from that, I think the beauty about real-time GraphQL is for backend developers, getting real-time GraphQL to work is not too different from getting to work for any other API or with any other approach. You kind of take the same steps. I would say it's been getting better recently. Not too many libraries exist in making it easier on the backend. But I think the nice thing for front-end development is that GraphQL has been actually taking a lot of these problems away that we're facing when we're taking in real-time data to an extent. In that subscriptions in GraphQL are a first-class citizen, and you can subscribe to events and get new data. And GraphQL clients with normalized caching are pretty good in updating queries with that new data. Where it gets complicated is real-time collaboration. And I think neither really takes the complexity out of that.
Yeah.
Although, to be fair, if you're probably implementing some CIDT stuff into tRPC, you might be having a better time, admittedly. Because in GraphQL, you're a bit limited in kind of the events you get. So you could write a new transport protocol that kind of embeds it into it. You could send some kind of primitive with GraphQL that makes it easier to determine when something happened or when someone else has made changes to the data that you're interested in. But I think that's a lot of hoops to jump through with GraphQL. And I've talked to people before who are working on real-time chats and real-time applications that are very collaborative. They were basically working on a Mac app that is open all the time, and that a team of people might, make changes to at the same time, and that they're joining rooms, calls, just like Slack huddles. And what they were complaining about is that GraphQL, after a while, if you're writing all the time GraphQL, it just feels like a hassle, because what they're actually dealing with is writing a lot of the CIDT primitives, the timing primitives of making sure that everyone sees the same things, or that everyone ends up in a consistent state of seeing the same stuff. And GraphQL doesn't help with that yet. So I think tRPC has the benefit of not pretending like it's easier.
Yeah, I mean, it's hard problems, and solving them in a generic way is very difficult. I feel like you might shoot yourself in the foot, or yeah.
It's a hard problem, and we had a good discussion about this, the three of us, where they're looking at it. It's funny because they look at it from a library maintainer perspective, which obviously makes sense. I look at it from an app developer perspective, which obviously makes sense. And I've done a lot of work with real-time, in particular around kind of like chat-based applications, which, I mean, obviously we're all familiar with chat. I think this is a great example of an application that has, it's kind of on the side of the spectrum of being extremely real-time, where every single thing in this UI can update. Like, for example, like this here, like that could update individually, right? Like this here person's name here could update individually. Obviously, you can have new chat messages coming in down here. That could update itself, right? So like, how do you effectively architect an efficient real-time system for that? And so like the way that we built it in the past was with Erlang. Lovely, amazing. You have to, you probably have a PhD if you can truly understand Erlang and supervision trees and all of that, however. You get into scenarios where if you model this with subscriptions alone, you have subscriptions relying on subscriptions that need to recycle themselves based on the result of another subscription, and it gets real messy real quickly. So in my opinion, I've done a lot of work with GraphQL in terms of cumulative diff live queries, actor-based concurrency on workers in the cloud, to kind of describe this entire UI as a data requirement, and then let the cloud do the diffing to then tell the client what diff to send to a normalized cache on the client to then compute this real-time view. But that's a whole ton of architecture to kind of do this efficiently. So to just agree with what's been said already, it depends. It depends on how real-time your application is. In my opinion, subscriptions are fantastic if you have a sprinkling of real-time. If you have a Facebook like counter that updates, you know what I mean? That's a sprinkle of real-time on an otherwise pretty static application. A subscription's probably fine. If you have something extremely real-time like this, it's good to know the primitives exist. How you use those primitives is up to you. Like the way I look at it, they're library maintainers. They're going to make a fantastic, sharp set of knives for the kitchen, right? But I'm the chef. I need to make the meal, And so they can give me the sharpest knives possible. How I use my ingredients to make that meal, it's still really up to you and what type of meal you're making for what type of, a customer you're making it for, right? So it's a tricky one, but it's just good to see that they've built it in its core. I think Phil, when you were building urql, you built it on Wonka, which was your kind of callback system, and you built kind of real time into the core of it. Kind of anticipating a lot of these types of concerns.
Yeah, it's basically a library that implements something like the observable spec. But what it was really useful for was expressing things very quickly. For instance, we built a bit of offline support into our normalized cache I say a bit because it's in a perpetual work in progress state because not a lot of people use it, and hence we're not getting enough feedback about that. But there's some minor complications doing things like that, and that you can get into a lot of different states. So for instance, there's a time period where you're loading your offline state from some sort of storage, maybe IndexedDB, maybe local storage. And while you're kind of rehydrating that, which might take a couple seconds or just milliseconds, you want to wait and queue up everything that your app might be doing, the queries it's asking for, wait for that data to come in, and then query that against the cache. Or alternatively, you might want to do that twice, query against the API, and raise that against your offline storage. And that's kind of what's been helpful with. And all of that is probably not as interesting as saying, I think Taz has talked about this view, and it's staring me in the face because we've built...
My terrible handwriting, clearly, yes.
Yeah, the handwriting as well. But when you're just starting to color this in, and the amount of queries and the amount of updates you can have in this app, even if we're not talking about subscriptions and a collaborative app, a normal front-end web app might be doing a lot of things at the same time, accidentally. You might write 2 queries, one for a list, one for a sidebar. Then you have a mutation because someone has clicked, I don't know, a like button on a Twitter-like view. Then they're opening a settings page and they're changing the name of their account. And all of this might actually be happening at the same time. And even though it's not collaborative and we're just talking about one app, there's a lot of changes happening. And when we're saying, well, normalized cache is great because everything updates accordingly, it sounds simple because, when we're saying you click save and it changes everything else. Because when we're talking about that, we're talking about one interaction. But when we're working on normalized cache, we actually had a lot of trouble in making that predictable because any of these things, of things loading, things changing, pop-ups opening, and other things happening, all of this can happen in like any order.
And then what? You can have like an optimistic update.
Exactly. You could have
with a subscription update layering over that, and then like how do you even deal with things like that? So like if I type in a message, so like just to draw it out here, if I type in a message and then I hit send, right, and then that's going to optimistically update a message in here. So it's going to say hi Phil. I can't spell. Hi Phil, or whatever it's going to say. That's optimistic until the server acknowledges it. What happens if another message comes in?
What happens if another message comes in, or you're also liking a previous message and you want to immediately show the user, I don't know, a heart symbol or something like that. All of these interactions could be happening at the same time. And I think even if we're not talking about real-time events or collaboration, we had a lot of trouble in actually giving a developer a consistent experience in that, so that they don't have to try all of these things in a different order and see if their GraphQL cache behaves in the correct way. And I think all of this gives me such a headache that I like working on apps that just deal with pages and just deal with loaders.
I remember I was with Phil when he was working all of this, and it gave me gray hair. So yeah. But yeah, no, they spent a ton of time. I think commutivity is what you called it in your normalized cache.
Commutativity.
Commutativity in your normalized cache, which spent a lot of time on the ordering of these types of interactions and so on and so forth. But I know we're almost out of time, so I want to be respectful. Is there any other questions in the room? Yeah, you were there in the back.
Yeah, so you kind of touched on this already, but I want to expand this further. How actually would optimistic UI work with tRPC and GraphQL? Because you would probably maintain your own client-side version of the exact same data. I'm not sure if that's... And then actually the other question is, how does that relate to then other parts of the app which might depend on the same data? How will those be optimistically updated as well, other than maybe prop building, which is not ideal? So how would I then update other parts of the app that has the same data optimistically?
Sure, Alex, you want to start maybe?
Yeah, so in optimistic updates in terms of tRPC versus GraphQL, in tRPC, so the state, now let's talk about React apps, because that's where we have a first-class library. By the way, tRPC is not tied to React. We have platform framework independent core. But in the context of React, you would drill into the React query cache, find that list or item you want to update, change something in that as part of documentation, and then if something goes wrong, you can roll that back. And that rollback is always complicated. You probably have touched a bit on like rollbacks.
In terms of commutativity.
In terms of commutativity. But yeah, that's basically it. So you have like blobs that are stored based on paths, and then you drill in and update those. It's all type safe because we know the shape of the data, so it's pretty easy to do it. Personally, I don't do much optimistic updates in the current application I'm working on because we don't need it. But there might be certain parts of the apps in the future where we do.
I think at least when we were working on it, there are different ways of doing it. And while I don't really want to touch on the details, we went a bit further than a couple of other GraphQL clients that shall go unnamed. In that, there's a lot of things that can go wrong if you're optimistically updating a lot of data at the same time. So if you choose to use urql and you choose to use our normalized cache, you can basically define the way in which data changes in response to mutation. For instance, liking a message, sending a message, things like that. And it's like a house of cards in that you have several queries and you're saying, well, this card changes and this card changes and this card changes. And if you do that several times, you can only say do that in a specific order. Let's say you have a house of cards and you're trying to rebuild it. You can't just take a card out at the bottom because it just all falls apart. The tricky thing with optimistic updates is that they have to be applied in a certain order. So it's applied in layers, like layers as in Photoshop, and they only make sense in a specific order. And then once we actually get data back from the server, we just undo that layer. We apply the real data. The advantage there is once you're getting data from the server, you know it's up to date. However, you still have to respect all of the other optimistic updates because optimistic updates take some sort of priority. So say you're liking a message, and because you're liking a message, a mutation runs. And let's say while you're doing that, you're kind of invalidating the entire view, and you're getting the entire list again. Now, that works because now the server is telling you, hey, this message is now liked as you want it. But let's say you're liking two messages at the same time. So now eventually, you'll get a response from the server that says, OK, here's the list. This message is now liked. But you're also getting a second set of that list, and a different message is liked. And you can't just combine that because now you have two results that disagree with each other. So there's a bunch of magic that has to happen to prevent that from happening, in that you don't want to update any kind of real-time data. You don't want to re-query anything while you're waiting for these optimistic updates to run through. All that is to say, it's nice that GraphQL has shared data and normalized caching, but in the background, there's a lot going on once you have multiple optimistic updates. So again, I'm not talking down on tRPC. I think there's a lot of advantages to just having a page's data and maybe even saying optimistic updates just modify that directly. And in the future, once we're done with those modifications, we just load the actual result again because there's nothing that can go wrong with doing that.
Very optimistic response. Wow, thank you, Phil. Cool, and I guess we'll take one last question before wrapping up. So you've already asked a question, Dan. You've already got stickers. Someone I didn't ask, I think I saw a hand up.
Can I ask one more? I don't need one more stick.
Go ahead.
Yeah, sorry, just a quick question for Alex. One thing I missed from switching GraphQL to tRPC is that the client got to decide what's the return type from server. And since because more obvious, because I'm using Prisma. Prisma did a good job using type infer because like you can specify what field include all the relationships. But that thing seems impossible in tRPC. And I know there is already issue in GitHub. It says it depends on the TypeScript feature support for the higher kind types.
Yeah.
But that issue, I think, created like 2014. It's still open, and I don't know, it seems like take forever for TypeScript to support that. So if not, do you have any backup plans for that thing?
I mean, do a faster response or split it up in several procedures? Oh, sorry, the question was again about being able to select the fields you want, or letting the client select the fields you want in a specific query. And my answer to that is to either split it up into 2 procedures or do one fat one that returns more data and overfetch a bit. The sort of like, and yeah, there is a TypeScript limitation to doing that with the type inference. But even if that issue gets resolved in TypeScript, and we might still not do it because of the sheer complexity that it has, the impact that sort of change has on CDN cacheability, or like that part. Like, it complicates a lot of things around it as well. So we might not never do it. Like, if you have that requirement, maybe use GraphQL.
We never even got into CDN cacheability. So I'll have to save that for another time. But I guess final question for both of you is, I guess kind of alluding to what kind of Yanni's question. Is there something that you look at in GraphQL that you like? Can you say something nice about GraphQL?
I mean,
I say something nice about tRPC.
I think I said a bunch of nice stuff already, but like, I feel like GraphQL really shines with like organizational complexity. Like, you have a really big team. You might have siloed backend, front-end teams. You might have like a really massive like microservices architecture, or like old services. They don't need to be microservices, right? But a sort of like as a beautiful gateway to a lot of whatever that is beneath that. And I think that is one of the amazing things with GraphQL. I obviously miss, that I already addressed, I miss the data transfer objects that I sort of can trust out of the box. So that's something we're addressing now. And it's just, GraphQL is amazing. And I don't have anything bad to say about GraphQL.
This was the thing, is I met Alex, and we just had a lovely chat about data architecture. And obviously online there's a lot of this versus that. But speaking to Alex, it was very lovely, very wholesome. We had a lovely chat, and it was very much this makes sense for this, and that makes sense for that. That's just really what it is at the end of the day. And yeah, Phil, something about tRPC.
So we talked about tRPC and GraphQL a lot yesterday, and I think we really tried hard to find things and points we disagree on, and it's pretty tough. I think we share a lot of similar opinions, and I think tRPC has been so successful so quickly because it's actually not only capitalizing on TypeScript, but TypeScript is not just a thing. But I think in web development, we never had something like TypeScript that so many people can agree on. I'm not saying everyone should use TypeScript. We've just talked about not using TypeScript in certain scenarios. But as a tool, I think we've never been in a position as a community where VS Code and TypeScript are so successful. And while they're not required, I think tools that embrace TypeScript can be really powerful and can make us a lot more productive. What I care about is making people more productive. I think that is the entire spiel, the entire thing of GraphQL. I think tRPC already challenges the GraphQL community in saying, okay, you do all of that to get a bit of data into your app. And I think the right tool for the right job, tRPC is the better tool for a lot of apps, specifically ones that are very page-based, very view-based, where a simple loader pattern would be, too messy. That's where kind of tRPC shines, going that extra step. But I think where it really shines is showing other tools that integration with TypeScript is really important, how it can make us more productive. So to kind of go back to an earlier point, GraphQL should get better at embracing TypeScript. And I think the kind of path forward to that is following the path that tRPC has taken.
Amazing, yeah, and what a lovelier way to end it. So thank you all so much for coming today. Thank you all for making this data discussion. I think a success. Like for me, I ended up really enjoying the discussion. I hope you did as well. Did you guys enjoy the discussion? Yeah. Yeah, it was good. Yeah. So it was a kind of a theory I had. We could have either had both of them give tech talks all night, or have a bit more of a discussion and involve all of you as well. So if this is a format that you liked, let me know. If you'd like tech talks, let me know. Just come talk to me later about kind of what you'd like. And if this is something you'd like, we try to do more of them with interesting people like Alex and Phil. So yeah, thanks so much once again, and thank you all for coming. Thank you.